Hello friends, today we will learn about the linear data structures. In linear data structure, we already seen two data structure. First one is the stack and another one is the. There are many types of linked list. Now we move forward about the first single linked list. Now, first question is what is the linked list? Introduction to linked list. When we want to work with unknown number of data values, or we can say dynamic number of values, we use a linked list data structure to organize that data. Linked list is a linear data structure that contains sequence of elements such that each links to its next element in the sequence. When we need the static data elements, then we use array. When we need the dynamic data elements arrangement, then we use the linked list. Each element in a linked list is called as node. Now we move forward about what is the node and what is the exact meaning of single linked list. Here we have one figure which shows the node of linked list. There are two parts in one node. One is the data and another one is the link. In data, store actual values, and in link part stores address of next node. Then we can say that using the link we can connect the node with next node. Single linked list is a sequence of element in which every element has link to its next element in the sequence. Here we have the example of the single linked list. Here are the first data element is the 10. Address of the 10 is stored in here, which is called as head of the list 1001. Address of the 25 is stored here 1004. Then we can say that 10 is linked with the 25 using this address part. Address of the 18 is 1008, which is stored here. Address of 55 is 1012, which is stored here. Now the question is, for last node, what is the address part? So here we can see for last node the address part is always null. Now we move forward about the operations performed on linked list. There are two operations which are performed in the linked list. First one is the insertion and the another one is the deletion. Already see linked list is the one type of dynamic structure. So we can say that there are three types of insertion is occur. Inserting at beginning of the list, we can insert an element at beginning. Also we can insert an element at the end of the list, and also we can add the element at specific location in the list, because linked list is totally a dynamic concept. So for insertion we have three ways: inserting at beginning of the list, at end of the list, and specific location in the list. Now we move forward about the algorithm, how the insertion is done in the beginning of the single linked list. We move forward the inserting at end of the list. So here we have one linked list, one node, which is the node we want to add at the end of the list. Step is common: create a new node with a given value, and now we want to add the node in the end of the list. So we firstly set new node next is a null, because last node of the list is always their null, next part is the null. Check whether list is empty. By checking the head is equal null, we can check head is empty or not, list is empty or not. If it is empty, then set head is equal to new node. If it is not empty, then define a node pointer temporary and initialize with head. We initialize the temporary because we need to find the last node in the list, so we need a temporary pointer. Keep moving the temporary to its next node until it reaches to the last node in the list. It means temporary next is equal to null. And the last step is set temporary next is equal to new node. This is how the insertion is possible in the single linked list at the end of the list. It's done at specific location in the list. Inserting at specific location in the single linked list. Insertion operations which is performed on the linked list. It means inserting at beginning, end and specific locations. Now we move forward about the deletion operations. There are three types of deletions operation. First is the deleting from beginning, deleting from end and deleting specific node. So here linked list is dynamic, so deleting from beginning, end and specific location is allowed in the linked list. So first we start with deleting from beginning of the list. So first condition we need to check is empty condition, because if there is a no node in the list, then we don't need to delete the element. So first condition is that check whether list is empty. Head is equal null, then list is empty. If it is empty, then display list is empty, deletion is not possible. If it is not empty, then define a node pointer temporary and initialize with head. Then we need to check if there is one node, there is only one node in the list, then we can delete that node. So we have the list which is totally empty. So next we check whether list is having only one node. How we can check this condition? Using temporary next is equal to null, then we can say list is having only one node. If it is true, if list has having only one elements, then head is equal to null and delete temporary and setting empty conditions, because list has only one element and we can delete that element. So list is now become the empty again. Right? If it is false, it means list is not empty, list is having not only one element, there are multiple elements in the list. Then we need to set head is equal to temporary next and then delete temporary. So this is the deleting from beginning of the list is occur in the linked list. Okay, move forward to deleting process in the end of the list. How we can delete from the end of the list? The first condition is common, check whether list is empty. If head is equal null, then list is empty, and if list is empty, then display list is empty, deletion is not possible and terminate the functions, because if there is no node in the list, then we cannot perform the deletion in the list. If it is not empty, then define two node pointers temporary 1 and 2, initialize temporary 1 with the head. Check whether list has only one node, same as we are checking in the beginning of deleting from the beginning of the list, same as here we also check list has having only one element. If list is having only one element and we are deleting this element, then there is no element in the list, so we need to set the empty condition in the list. So check whether list has only one node, temporary 1 next is equal to null, then if it is true, means list is having only one element, then set head is equal to null and delete temporary 1 and terminate the functions. It means set all the ends. Now we move forward. If it is false, that means what? If list is not empty, if list has not having only one element, list has a more than one elements, then set temporary 2 is equal to temporary 1 and move temporary 1 to its next node. Repeat the same until it reaches to the last node which we want to delete. Okay, and finally when we reaches to the last node which we want to delete, then set temporary 2 next is equal to null and delete temporary 1. So this is how we can delete the last element from the list and set another last element, and next part of that element is the null. So this is the deleting from end of the list. Now we forward about the specific location deletion. Here also we need to check empty conditions, because if there are no node in the list, then there is no need to delete the element from the list. So check whether list is empty. If head is equal to null, then list is empty. If it is empty, then deletion is not possible and terminate the function. If it is not empty, then we need to define temporary 1 and 2 as we defined in previous algorithm. Right? Initialize temporary 1 with head. Keep moving the temporary 1 until it reaches to the exact node to be deleted or the last node. We need to move the temporary 1 to the specific locations or until the last node. Every time set temporary 2 is equal to temporary 1 before moving the temporary 1 to its next node. Now we need to check specific node or specific locations are there in the list or not. So if it is reached to the last node, then we can say given node not found in the list. If there is a specific node is not available in the list, then deletion is not possible. If it is reached to the exact node which we want to delete, then check whether list is having only one node or not. Right? If it is reached at specific location, then we need to check as previous algorithm, list is having only one element. If list has only one element and we are deleting this element, then list becomes again empty. If list is only one node and that is the node to be deleted, then head is equal to null and delete temporary one and set all the empty conditions. If list contain multiple nodes, means list is not empty, list is having not only one element, list contains multiple nodes, then check whether temporary one is the first node in the list. So how we can check? Using temporary one is equal to first node of the list. If temporary one is the first node, then move the head to the next node and delete temporary one. Specific location, specific node is the first node in the list, then move temporary one to its next node and delete the first node. If temporary one is not first node, then check whether it is last node in the list. If it is not first, then we are checking this is last or not. How we can check? Using temporary one next is equal to null. If temporary one is last node, then set temporary 2 next is equal to null and delete the temporary one. If temporary one is not first node and not last node, it means it is the specific node given in the list which we want to delete, then set temporary 2 next is equal to temporary 1 next and then delete the temporary 1. So this is how the conditions is checking for the deleting a specific node from the list, and at the end deleting is done at the specific node from the list. So this is how the operations perform on linked list. It means deletions and insertions are performed in 3 ways because linked list is totally a dynamic. So there are 3 ways to inserting an element in the list and deleting element from the list. Okay, so this is how the operations work on linked list. Thank you all of you. If you have any query, then write in comment. Thank you.